Have you ever wondered what type of software a computer must have to function? So this is the topic for our video today, which is called system software. My name is James. I'm a computer science graduate turned teacher, and in this video series, I want to give you a full A-level computer science education. So let's look into what is system software. To define it, it is the type of computer program that provides a platform for running application software, which is all the other software besides system software, and manages computer hardware resources. So all these different softwares here fall under the umbrella of what we call system software. The OS, utility software, program library, language translator, and eventually the IDE. So let's look at what an operating system is. So before the operating system was invented, punch card and punch tapes are the tools that are used to store programs and data. This is what will happen when you want to use a computer before the operating system era. You have to put your program on a punch card and data on a punch tape. As the programmer or the user, you have to insert these cards into what we call the card reader and tape reader respectively. And you press a physical run button, and once the program is run, you get the output printed on the line printer. As you can see, this method is not really efficient because what if you have multiple programs to run? Then you might have to do this all day long. And this is exactly what happened in the era before operating system. What the operating system do is that it controls the hardware and interact with the application software. Think of it like the middleman between the hardware and application software. What the example that we discussed just now, the human was the middleman. And now we are delegating the role to the operating system. So let's look into some of the tasks carried out by the OS. The first one is it provides a user system interface, which is an interface that enables user to make the software and hardware perform meaningful tasks. Think of it like an interface for us to communicate with our device. And there are two types of user interface in your syllabus. The first one is graphical user interface, in which you interact with the computer using graphics by pressing icons on your desktop, for example. The other way is called command line interface. Not a lot of people have used this, but programmers will use this very often to communicate with the device. The second task that operating system do is that it also provide a program hardware interface. Think about it. All the software that you use, for example, I use Final Cut Pro to record my video. These software requires the usage of certain hardware like computing power and RAM to run. And what the OS does is that it manages hardware, it allocates hardware for software to be used. So it ensures that software can effectively utilize hardware capabilities to perform specific tasks and functions. So as a programmer, if you are the creator of Final Cut Pro, you do not need to know how hardware functions. You just need to follow certain procedure because operating system will allocate all these things for you. The third thing that the OS do is that it manage resources. So resources in this way refers to the computing power and also the memory. There are many processes that can be running at the same time. So a process is a program that has begun execution. Process 1 could be your Google Chrome. Process 2 could be your Spotify app, etc. And these processes require RAM and processing power. So the OS will be the one that allocate RAM and processing power to each process because it will know how much RAM it needs, how much computing power it needs. This is one of the things that the OS do. So look at this diagram here. There are many processes running, but let's say the computer can only handle one process at a time. This is when the OS comes into play. They allocate time slot for each process to run, which means that each process will get sufficient time, sufficient resources to run it, and it will also resolve conflict if two processes need to be running at the same time. And for example here, if process 1 and process 2 need to be running at the same time, the OS will arrange it in a way that, alright, process 1 will run first, followed by process 2. So this is a major topic in operating system study, but today we're not going very deep into it. This thing is called scheduling. The fourth thing that the memory do is called memory management. So there are a few aspects of memory management. First of all, the OS ensures that no two processes can attempt to use the same memory location. So in this case, if I have 3 processes, all these 3 processes will be in a different location in the RAM. So that's the first one. And the second one is the selection of the memory organization scheme. It is also done by the operating system. It aims to optimize the utilization of restricted memory capacity, such as employing virtual memory through paging or segmentation. Basically, virtual memory is, let's say you are running many programs and you don't have enough RAM. So a virtual memory is part of the hard disk that is used as a temporary RAM. And the OS will be responsible for allocating, alright, this process you will use virtual memory for now, and then the other second it will be used by another processes. So this is what the OS does. It do this automatically for us so that the user doesn't have to worry about it. The third one is optimizing memory usage, entails making choice regarding which processor should reside in the primary memory at a given moment, which is something that I mentioned. The OS will know whether process 1 or process 2 needs the physical memory now. If process 1 is more urgent, they will allocate process 1 to have that instead of process 2. This is what the OS does in terms of memory management. Device management. The operating system handles the installation of the appropriate device driver. So device driver is a software that allows a certain hardware, for example, a keyboard, to communicate with the computer. So the OS will help us to install all this device driver so that as a user, you don't have to go and find the device driver for a webcam, for a printer, for a keyboard. These are all carried out by the operating system. File management. 3 main features here. The file naming convention. So this is some of the experiment I did on my MacBook. So if you will try to create 2 folders with the same name, you will receive this warning. Again, this action here is detected by the operating system. The OS also control the directory structure, which is how you organize your files by creating folders. So these are also features enabled by the operating system. Lastly is the access control mechanism. It's the process of regulating and restricting access to data or resources, ensuring that only authorized entities can access specific information or perform certain action. So user management. Let's say 3 person is using this computer here, and the OS will help you to set access control for different people. Okay, the last 2 tasks is the security management. OS handle data recovery in cases of data losses, usually via a backup program. And it prevents intrusion by installing antivirus, anti-hacking software. And it also ensures data privacy, possibly by encrypting your data so that no one can read what is on your computer. Last but not least, error detection and recovery. The operating system should be capable of pausing an ongoing process and offering error diagnostic when necessary. In critical situation, it must be able to systematically shut down the system without any data loss. So this is the kind of protection that we do not see very often, and yet they are done by the operating system. So these are the 7 features: user system interface, program hardware interface, resource management, and memory management, device management, file management, security management, error detection, and recovery. So these are all the things that the OS does. So let's look into the second type of system software called the utility software. Unlike operating system, utility software is a software designed to perform specific tasks. So each utility software has a specific role. So their purpose is to maintain the overall functionality and maintenance of a computer system. Something that they do include disk cleanup, antivirus scanning, or file compression. So it's not executed during regular operation of the operating system, but then it is a program that is initiated by us, the user. or the operating system when necessary. So I want to show you a few examples of utility software. The first one is the hard disk formatter and checker. So the formatter will erase all the data. Let's say you are buying a second-hand laptop. This is what the hard disk formatter will do, just erase everything formatted. Second feature, it establishes the file system on this using a directory that link file recognized by the OS to specific physical location. So let's say you have two very important folders, folder A and folder B. What this software will do is that it will allocate physical memory, let's say here and here on the disk, for folder A and B respectively. Lastly is to divide the disk into logical drive if necessary. So the first type of utility software is the hard disk formatter and checker. The second software is also related to, alright, before that, hard disk formatter and checker will also help to repair your disk. So usually a disk is considered a flaw when a particular sector cannot be used to store data anymore. And what this software does is that it will prevent this sector, it will either repair it or it will prevent this sector from being used to store data. Otherwise, your data could get corrupted if it's stored in a wrong sector. The second type of utility software related to hard disk is the defragmenter, which is something I believe I've mentioned in the previous video. So what it does is that it organizes the hard disk into proper form so that your hard disk can process data quicker. So defragmentation happens when you are continuously creating, modifying, and removing files, which leads to different files. The data of it is separated, it's segregated into different locations. In this case here, it's really remember a hard disk drive, they have something called a moving heads. So when they want to read data, it'll just read from, let's say I want to read the purple highlighted data. The head will move from here to here to here in order to read all the data related to the purple highlighted file. And by moving in this particular fashion, it slows down the computer and it affects performance. So a defragmenter will organize it so that the hard disk head doesn't have to move that much. So it reorganizes the fragmented data on the disk to improve its performance and speed. The third type of utility software, backup software, it creates duplicate copies of files and data from a computer or network, which can be used to restore the original data in case of data loss, corruption, or accidental deletion. So how they achieve backup is that they will set up a timetable for conducting backup, creating exact copy of what you have, and they will generate a fresh backup file only when there's modification, which means they will likely do it every once in a while because you're constantly changing data, right? So the fourth type of utility software, file compression. I believe you all have tried to zip file before. For your information, once you zip your file, the file size of it will be reduced because this is what file compression software do. They compress it in a way that doesn't affect data performance. So in this screenshot that I have taken, when you compress this file, what happened behind the hood is that the file compression software compress these three individual files into one archive file. So you can try it on your computer if you want to. Fifth type of utility software, the virus tracker. It scans and detects malicious software and potentially harmful code within the files and programs to ensure security, it is a program that runs continuously to check whether there is any malicious software that is on your computer running. If that's the case, they will stop the process and even warn you if necessary. So these are all utility software. You can see that this software, they enhances the functionality of a computer to make sure that you have a good experience using them. So the type of system software, go back. The first one is operating system, followed by utility software. Now we're looking at program library. So program library is also called subroutine. It can be a bit hard to grasp if you haven't started coding yet, but let me explain. So think of some codes here. Let's say a programmer has written some codes that will be frequently used by other programmers as well. So this is when the programmers will make these codes a subroutine so that if other programmers want to write the exact same code, they don't have to write it from scratch. They can just write a line on their code editor to use this chunk of software. So this is exactly what subroutines are. They're designed for specific operations written by some good programmer. And then if the other programmers want to use it, they can integrate into their own code, reducing the time and effort needed by using pre-tested code snippets from a subroutine library. Meaning this code have been tested to be functional, so they don't have to invent it from scratch again. So, as you know, source code will eventually be converted into machine code because this is the only language that a computer can understand. And the executable code cannot run independently, must be linked with any utilized subroutine code, which means that if the programmer uses some subroutine, before they run the code, it has to be linked to where the subroutine was written. And as a result, the subroutine has to be copied over before it runs. It means that it will take up a lot more space. It also increases memory usage when more than one process using the routine. Therefore, to solve this problem, a dynamic link library is introduced. So there are a bunch of words here, but let me explain it in a clear way. So it is a collection of executable function and procedure that can be dynamically loaded and accessed by a program at runtime, meaning you don't have to copy it over. The advantage of this library is that the executable code only requires a small code inclusion. So instead of copying the entire source code into the program, they only need to write a small code inclusion to indicate that, hey, I'm using this subroutine. And this leads to reduced storage space and also reduced memory usage. So when a new version of the routine is available, it can be loaded into memory, automatically upgrading any program using it. One disadvantage of dynamic link library is that sometimes required library is not available or is incompatible, and performance can be affected due to the need for runtime linking, as we are linking our code with the subroutine. So this can cause delay during program execution. So these are some advantages and disadvantages that you need to understand and memorize. Okay, the fourth type of system software, which is needed in particular in programming, which is Translator. I have a few lines of programming code here. It's written in Python. For your information, all this code will eventually be converted into 0 and 1. But which software does that, right? This is exactly what Translator do. It converts human-readable code into machine-readable code. So there are two different types of translators. The first one is interpreter. How interpreter works is that it translate and execute high-level code line by line during execution. I have 3 lines of Python code here. I want to show you how it will be run. So how it works, first step. The first line of the source code is processed, and then the line is analyzed. In this case, if an error is detected, it is reported and the interpreter program will stop execution, which means if in case of an error happening, line 2 will not be run. If there's an error in line 1, line 2 will not be run because the interpreter will stop it. If there's no error, the source code line is transformed into an intermediate code. So the interpreter program employs this intermediate code to perform the necessary operation. Think of it like a step-by-step operation, which will just execute the code until an error is reported. And if there's no error, step 2, all this step will be repeated for line number 2 until an error is repeated or until the program has terminated. This is the first type of translator. The second type of translator is called the compiler. So instead of going through the code line by line, they translate the entire high-level code into machine code all at once. So let me explain how this works. The first line of the source code, let's say this is the code, is read and it will be analyzed like what happened in interpreter. If an error is detected, this is recorded. So as compared to interpreter, the program doesn't stop. It just records the error. And if no errors are identified, the source code line is transformed into an intermediate code like what happened in interpreter. So the only difference is that it doesn't stop when an error occurred. It just keeps going until it finishes compiling the whole program. So when no errors are found in the entire source code, the entirety of the intermediate code is translated into object code, which is something that can be executed. And if any error identified, a list of this error is generated as output and no object code is produced. So unlike interpreter, execution of program can only begin when the compilation has shown no errors. So in the previous example, when we talk about interpreter, if this line is okay, they will just run the code directly. But in this case, not until the code has shown that it has no error, that it cannot run. So I have listed some advantages and disadvantages for the programmer first, and then for the user. For the programmer, identifier error can be recognized in real time and promptly rectified because it will stop when an error is detected. So unlike compiler. But the disadvantage is that in a specific program execution, section of the code with syntax error might remain inaccessible, resulting in any lingering error being detected only at a later stage. And source code has to be distributed to the user, which means if the programmer has written this code and they want to sell it to other people, they have to distribute the entire source code to other people. So as for the compiler, the benefit of it is that because it will generate an executable file, this means that instead of giving the purchaser, the user, the source code, in case you want to keep it as private, the executable file can be distributed to user without having them access to the source code. So in interpreter, you must give them the source code, but in compiler, you don't need. But as for compiler, it requires more time for the initial development, meaning it takes more time to write code that requires a compiler. So that's the advantages and disadvantages for the programmer. And for the user, on the other hand, the disadvantage of an interpreter is that every time an error-free program is executed, both the interpreter and the source code need to be accessible. Meaning, to run the code as a user, you need the source code, you need the interpreter. So that's the disadvantage. For a compiler, the advantage for the user is that the execution speed achievable with compiled object code exceed what can be obtained by an interpreter code. You can run it faster. You can run the executable code faster than as compared to using interpreter, because it's no longer interpreter line by line. It's just run it. And as for the compiled program, only the object code has to be available each time an error-free program is run, meaning you don't need a compiler as a user to run the code. The disadvantage is that it is less secure because it could contain a virus. Someone could put a virus into the executable code. So that's some differences between interpreter and compiler. So irrespective of whether an interpreter or a compiler is employed, a program can only be executed on a specific computer with a specific processor if the interpreter of compiler program has been tailored for that particular processor. So that's the requirement. If the option exists, meaning if you can choose, the preference for an interpreter during program development is warranted due to the following reason. A single error in the code can trigger the occurrence of multiple additional errors, and because of that, you want to identify and rectify error as soon as possible, which is something that interpreter can do because it interprets codes line by line. And the debugging tool integrated with the interpreter expedite this process. Of course, if the usage of compiler will be justified if the program is assured of minimal errors in the program, which mean you don't think there's any error. All right. So a compiler allows for the creation of an executable file that can be distributed for general use, result in faster execution. So they might be a bit slower to develop, but then as the user, you can execute it a lot faster. So this is some facts about Java. When Java was developed, it introduced a distinct approach to its utilization, requiring a Java virtual machine specific to each type of computer. Upon writing a Java program, it's initially compiled into Java bytecode, which is then interpreted by Java virtual machine during runtime. So in this case here, Java is using both compiling and compilers and interpreter. The portability of Java bytecode enables its transfer to any computer equipped with a Java virtual machine. So the last part, that's all for Translator. It translates programming language code into binary code. So the last example of a system software is the integrated development environment. So it is a software that programmers need to develop software. Yeah. So it provides the following features: code editing, debugging, and building capabilities, all within a single interface. Some examples include PyCharm and Visual Studio Code. So in this section, I just want to show you some of the feature of an IDE so that when you start programming, you don't take them for granted. You know that it's done by the IDE. First feature, the pretty printing. So I have an example of a Python code here. As you can see, the colors here, they are used deliberately to represent different things. So for example, the comment is in green, the keyword is in blue, and the variable name is in black. For pretty printing, they also allow automatic indentation to allow you to see your program in a better view. Color-coded data type also part of it. Pretty printing. Second thing, context-sensitive prompt. For example, I created two variables, number 1 and number 2. If I want to print out number 1, instead of typing the entire thing out, I just need to type the first character, and then it will show me what are the possible values that I want to type in. And this saves time when you are coding. Dynamic syntax check. So for example, if I were to make a typo error in my code, it will automatically correct me and let me know what is going on so that I don't have to proofread it myself. In this example, it's the same. Dynamic syntax check. Expanding and collapsing code block. So initially, this is the entire code for the play function. And if you want to remove clutter to focus on other aspect of the code, you can simply collapse or expand it anytime you want to. Lastly, it's about debugging. A debugger in an IDE can help identify and rectify error or bugs in the code by allowing developers to track the execution of programs step by step and inspect variables and expression at different points. So a debugger is usually included in an IDE, and that helps you to debug. Debug means to find errors in your code easily by going through the code line by line. So this is all about IDE, and this is also all about system software. I hope you learned a lot from this. Let me know in the comment section if you have any question, and I'll hope to answer that, and I'll see you in the next video. Thank you for watching.